Alright, let's look at number 1. Find the value of the 6 trigonometric functions for theta. So we're going to find the sine of theta, the cosine of theta, the tan of theta, and then the cosecant of theta, the secant of theta, and the cotangent of theta. So this is where we are standing. This makes this our opposite, our adjacent, and our hypotenuse. And so you can see that we're missing our hypotenuse. So we're going to have to do the Pythagorean theorem. So a squared plus b squared equals c squared. So 36 squared plus 77 squared equals c squared. So I get 1296 plus 5929 equals c squared. So that gives me 7225 equals c squared. Now square root both sides, and I get c equals 285. So before I can even start working with the trig functions, I need to find the hypotenuse, which is equal to 85. So remember our definition of the ratios. So we have SOHCAHTOA, so the sine is going to be the opposite over the hypotenuse. So if I'm standing on theta, my opposite over hypotenuse, so it's going to be 77 over 85. My cosine is going to be adjacent over hypotenuse, so 36 over 85. And my tangent is going to be opposite over adjacent, so 77 over 36. And you're going to want to make sure that these fractions can't be reduced. And so now the cosecant is just a reciprocal of sine, so all you got to do is flip these fractions. So here are our 6 trig functions for theta. So we want to find the unknown side lengths for each triangle. So let's start with this one. So if this is a 30, that's going to make this a 60. So we're going to start with our 30, 60, 90. And so our ratio is 1, 2, 3. Or 1, 1 rad 3, 2. So we're given the side opposite the 70. I'm sorry, opposite the 60. And so we put that underneath the 60, so we get the 7. And so now you just pick a side. So let's pick the x. And so we'll put that under the 30. And so now all we do is cross multiply. That's supposed to be an x. So as we cross multiply, we get 7 equals x rad 3. So now we divide both sides by rad 3. And we don't want to have the radical, so we're going to multiply by 1, or rad 3 over rad 3. And so I get 7 rad 3. And this is the square root of 9, which is just 3. That means x is equal to 7 rad 3 over 3. Now to find y, we're going to do the same thing. Just put that under the 90. And we can set up this proportion now. So we're going to look at these two fractions and cross multiply. So here we get 14 y rad 3. Same process, divide by rad 3. I don't want to have rad 3 on the bottom, so I multiply by 1. So we get 14 rad 3 over 3. Now, if you recognize the ratio, at the 90, the hypotenuse is double the side opposite the 30. So since this was 7, if you just double that, you would have got 14. You didn't need to do all that work, but it doesn't hurt. So now we're going to solve this triangle. And so it's a 45, 45, 90. And so remember that that ratio is 1, 1, 1 rad 2. And so if I'm given the side opposite of being 6, since they're both 45, they're both going to be 6, so I know this is 6. And so I don't know this side here, the r. So I can make this a proportion now and cross multiply. And so I get r is equal to 6 times 1 is just 6 rad 2. All right, number 3, draw an angle with the given measure in standard position and find the measure of the reference angle. So we're going to start here, and obviously that 682 is bigger than 360, so we're going to go around once. So as we go around once, now we minus 360, and so now we have 322 more degrees to go, and so we keep going. So there is 90, 180, 270, and so 322 is going to be somewhere over here. And so now we can draw the terminal side. And so from all the way around is a measure of 682 degrees. Now the reference angle is always going to be the angle from the terminal side to the x-axis. So if it's on here in the quadrant 4, I need to do a 360 minus 322. So that gives me 38 degrees. So my reference angle here would be 38 degrees. Now let's pretend that our terminal side was over here. So let's just let's pretend we had a measure of, let's make it 200 degrees. So if we're 200 degrees, 200 degrees, and I want to find the measure from the x-axis to my terminal side, what would I subtract it by? Well, I would subtract by 180, and so this would be 20 degrees. Now let's pretend we had an angle of 160 degrees. That'd be about here. And so we always want to have our reference angle less than 90 and close to the, has to go to the x-axis. So if this were, I forget what I said, 160 degrees. So I want to figure this out. I'm trying to figure out what it makes to 180. And so that'd be 20 degrees. Now if I just gave you a 30 degree angle, obviously that angle would also be the reference angle because it's less than 90 and we have it here. Alright, so those are the 4 different possibilities you have. So now let's look at negative 210. So now we start here and we're going to go negative. So there's 90, 180. So it's going to be somewhere here. So this angle here is 210 degrees. So it went past the x-axis, so we want to figure out how much higher it went, and so we just minus that from 180, and so that would be 30 degrees. Alright, so we have P as a point on the terminal side of theta in standard position. Find the values of the 6 trig functions for theta when given the point 8, negative 15. So if we were to go over here 8, and then down negative 15, this point here is the point we're talking about. So here's the terminal side. So now we make a right triangle. So from here to here is 8, from here to here is negative 15. And so now we need to do the Pythagorean theorem to figure out what this length here of the hypotenuse is. So it's going to be 8 squared plus 15 squared equals c squared. So doing the Pythagorean theorem, we get 289. Now we square root both sides, and so my hypotenuse would be 17. So right here, this is theta. And so now we just find the 6 trig functions. So the sine of theta, cosine of theta, and the tan of theta. We'll start with the 3 basic ones. And so remember, sine is opposite over hypotenuse. So it's going to be opposite over hypotenuse. So it'd be negative 15 over 17. Cosine is adjacent over hypotenuse. So it'd be 8 over 17. And the tangent would be opposite over adjacent, so negative 15 over 8. And so now the cosecant is just a reciprocal of the sine, so that'd be 17 over negative 15. The secant is just the reciprocal of the cosine, so it'd be 17 over 8. And the cotangent is just a reciprocal of the tan, and so that'd be 8 over 15 negative. Now notice here I put the negative on the outside. Typically you don't put the negative on the bottom, so it's okay to have it on top, it's okay to have it on the outside, but typically we don't write it on the bottom.